All right, guys, we're looking at target 3.1. Our first one in our new unit, KC3, and KC3 is all about circles. So today we're just going to look at identifying and using parts of circles. So our vocabulary, what is a circle, right? So a lot of us know that what the shape of a circle looks like, but what is the actual math definition, okay? And the actual math definition is, the set of points that are equidistant from a specific, a specific point and that specific point is the center. Okay. So if I draw a circle here, it's not the most beautiful circle, but we have our center, and then every point, if I choose any point on this circle, right, there's an infinite many of them. I can make little dots all the way around. Right, every point is the same distance if this was a perfectly drawn circle, which it's not. What's the radius? The radius is the distance from the center to a point on the circle. If I start at the center and go to any point on my circle, that's the radius. A chord is a segment. So that's just a line, right? A line segment. Connecting any 2 points on the circle. Okay. So I could choose a point here, and I could choose a point here, and I'm going to connect them, and that is a chord. Okay, so a chord is connecting any 2 points on a circle. And then we have a diameter, and our diameter is just a special chord. A special chord that goes through the center. And we've seen diameters before, right? So I would specifically have to choose points on opposite sides of that center, right? And that's our diameter. And as we've seen before, the radius is half of the diameter. Right? We used that idea before in some cases, and we'll probably use it again in this unit. All right. So now we want to look at naming these things. Name the circle. Okay? So we name the circle by the center. So this is circle. How we name the circle is we draw the circle symbol and E. Okay. If you just say E, that is technically our center. How would you name our center? If it's just the letter, it's just the point. Okay, so it's point E versus circle E. Okay. A radius is a line. And we name lines with the 2 endpoints with a line over them. So there's several radiuses here. We're going to name this one, right? So the 2 points I connected were E to F, and it's a line, so I'm going to put the line over top. Then chord, same thing, a chord is a line. So our chord is here. Again, that is J, K, the line over top. And then last but not least, our diameter, which again is a line. It's this line. So HG with a line over top. Okay? For all of these lines, it does not matter the order that you go in. Radius EF and radius FE is the same thing, right? I can go either direction. All right, and that's kind of it for those things. The next thing you want to look at is a central angle. So a central angle is an angle created by two radii. Radii is the plural form of radius. Okay. So there's one radius, two radii, two radii, and the vertex is at the center. So here's an angle, right? So really, those are our two radii. So this is the angle, and so this would be angle B. Or angle, I could say I went from A to B to C. Both of those are ways to name that angle. Looking at example 2, find the value of x. One thing we need to know, a whole circle is 360 degrees. So a whole circle is 360 degrees. So if I was to find x here, right, I have x, this angle over here is 145 degrees, and this angle is 165 degrees. So I could just say x plus 145 plus 165 equals 360. 310, I believe that is. And yeah. Ooh. So x plus 310 equals 360. And then I'm just going to subtract 310. And x equals 50 degrees. All right, let's look at our next page. The next thing we're going to look at is more vocab, lots of vocab for this first one about all different types of things. Okay? So, one thing I want to talk about before arc is what circumference is. So we'll just write that in up top. Circumference. And circumference is the length around the outside of the circle. It's like perimeter, but for a circle. Probably heard of circumference before. The length around the outside. I cannot spell today. Can't even spell circle. Okay, so circumference is the length around the outside of a circle. So then we have to think about what an arc is. And an arc is a portion of the circumference. Really struggling. I forgot the U. Circumference. Right, a portion of the circumference. So a minor arc is an arc that is less than 180 degrees. Okay? So that's half the circle. Right, 180 degrees is half the circle. The whole circle is 360. So here, right, I have a minor arc. And how we call that is, I'm going from A to B, but before we connect them with a line, I'm not connecting them with a line here. I'm connecting them with an arc. So like a little rainbow over them. So that's arc AB. A major arc is an arc that is more than half the circle, or more than 180 degrees. So if you look here, right, it's still A to B, but if you just say A to B, I'm going to take the shortest path, right? And I don't want to go around the shortest path, I want to go around this longer path. So how we tell it to take the longer path and not the shorter path is, I am going from A to B, but I want to make sure I hit that D on the way. Okay, so it's A to D to B. So your major arcs always need 3 letters. Your minor arcs only need 2. Okay, because I'll always take the shortest path between 2 points. Arc A, B, B. For a semicircle is an arc that is exactly 180 degrees. So here, same thing. I'm going to name it the same way. A to D to B. I could also say arc AB, but that would be this semicircle along the outside instead of this one. Both are semicircles, but the one they had darkened was A to D to B. So semicircles could be named as arc AB or arc ABB, depending on which one you're looking at. Okay, so it could fit either of those rules. Okay. One last thing to mention is for any arc, the measure of the arc, again, putting this M in front means measure, is equal to the measure of the central angle. And we'll look at that also in some of our examples. So the measure of the arc equals the measure of the central angle. So let's look at example 3. Okay. PM is a diameter. Identify each as a major arc, minor arc, or semicircle, then find its measure. Okay. So the measure of arc MQ well, MQ is definitely less than 180 degrees. It's less than half my circle, so it's a minor arc. And, right, the measure of MQ is going to be the same as this. And if I cut this in half, that's exactly 180 degrees. So it's going to be, right, this is 115. This is X. sorry for the bells. Alright, those add up to 180. So x plus 115 is going to equal 180. So x equals 65 degrees. Now if I do n to n to p, that's this arc here. Well, that looks like it's exactly half my circle. So then we have that MNP is a semicircle. So if I put an x here, that means x is automatically 180 degrees. Right? Semicircles are equal to 180 degrees. Then we have M to N to Q. We're doing this whole piece here. Okay. Well, I already know this piece, right, was 180, that blue piece. And that this piece over here is 115. So that means I'm going to add that 115 to the 180. And I'm going to get 280, 295. So it's kind of just adding up all of your pieces to find the measure of these arcs or angles or whatever we have. Right? So let's look at example 4. Find each measure. So the measure of A to E to D. Well, this is 63, and this is 90 because of that square. So I'm going to add them both together. Then A to D to B. Well, this is a diameter, it goes through the center, so that's 180. And this is still 63. So I'm going to add those together. And then C to E. Well, again, this whole half is 180. And then if you look here, we have vertical angles. All those angle rules we knew before, we still know. So this one, I have 180 and I'm taking away that 63. And that's 117 degrees. Okay. So again, a lot of this is just kind of practice to kind of get you better at knowing, like, am I adding, am I subtracting? What other angles can I use? And we'll be practicing that a little bit tomorrow. Otherwise, have a wonderful rest of your day.